One famous tool in inventory management, when the demand is deterministic and many other assumptions that we usually use, we call this technique as economic order quantity. The purpose of this technique is to determine the minimum quantity to order so that we can minimize all the costs related with the inventory. Let's see and discuss about that.
In this video, let's discuss about the first and famous model of the economic order quantity. This is the model that used and based the assumption that the demand, lead time, and everything is deterministic. First, let's see and discuss about the what we call it independent and dependent demand. Independent demand is the demand of the item that is independent for any other item in the inventory. Usually this is for the final product. On the other hand, there is a dependent demand. The demand for this item depends on the demand for other item in the inventory. The example of this dependent demand is the inventory or the demand for the spare part. Of course, the number of spare part that we need depends on the number of product that we already sell. Here in this video, we will focusing on the independent demand. Let's talk about the cost that is occur in the inventory. The first cost, for sure, this is the holding cost. This is the cost to keep, to maintain, to hold, or to carry the inventory over time. This is including the renting the houses, using some technology and electricity to maintain the quality of the inventory and so on. So this is covers in the holding cost. The second is we call it the ordering cost. This is the cost of placing an order. There's an administrative cost, of course, and also receiving a goods, including the transportation. The third one is we call this one setup cost. This is the cost mostly related with the workforce or the employee or to pay for the regular pay rate to prepare a machine or process for the manufacturing an order. So this is the setup. In this setup cost is happen once. Yeah, it is happen once. Based on this cost, we can build the economic order quantity model that we commonly call EOQ model. But first, let's see the important assumption of this economic order quantity model. The first assumption is demand is known. So if demand is unknown, we cannot use this one. The demand is constant. Yeah, in this case is deterministic and also independent. It's not depend on others' demand. The lead time is also constant and also known in this case. And the receipt of inventory is instant and complete. It means when we order today and then we can receive the inventory also today and in complete form. Yeah, not 50% coming today and next 50% coming next week, for example. Yeah, not like that, but we receive it complete and instant. Number 4, we assume in this EOQ model that the quantity discount is not possible. There is no quantity discount. Number 5, the variable cost that we will consider in here is setup cost and holding cost. Number 6, yeah, based on this model, stock out can be completely avoided because everything is deterministic. when we see the inventory or the characteristic of inventory usage over the time, we will have the pattern like this. The inventory, for example, we have the level of inventory or inventory quantity is Q, or this is the maximum inventory level that we have, the capacity of our warehouses, and so on. So this is, we have Q as the maximum inventory level. By the time we consume this, so the number of inventory, so this number of inventory level, this axis is time, number of inventory level that we have is decreasing over the time. And then at some point, for example, in this point, we purchase an order, and receive against, the amount of item to fulfill our inventory, and we can reach the maximum inventory level. And then we consume again, and then we order again, consume again, and so on. So based on this pattern, we can understand that the average inventory that we have is equal to Q divided by 2. How we determine the optimum number of quantity to order? In this case, we have to understand the characteristic between the two costs that is included in this model, which is holding cost and setup cost. The holding cost is equal to, this is, since like this is the variable, this is type of variable cost. So the holding cost is equal to the average inventory on hand multiplied by the holding or carrying cost per unit per year. So based on this formula, if we draw the line, if we draw into the curve, and then we have this straight line for the holding cost. And then the second cost is setup or ordering cost. So we combine both of them, setup and ordering cost. Setup or ordering cost is the larger the order quantity is, the better, or the lower the more the cost that we have to pay, is lower, is getting lower. So the setup cost calculation is D in this case is demand divided by Q, D divided by Q multiplied by S, setup or ordering cost per year. For example, if we have per year D is equal to 1000, for example, and each time we order 100, and then so we need to order how many times? In this case, it means that we have to order 10 times. So 10 time order multiplied by setup cost. So the higher the Q is, in this case, Q, the better. It means the setup cost is lower. But oppositely, the higher the Q will increase the holding cost. So this is a trade-off between these two, setup cost and holding cost. So at which point this cost will be the minimum is, we see in here. So this is the minimum total cost. This is exactly at the intersection between the holding cost and setup cost. So when we calculate this one, so we got the optimum order quantity, in here, and the formula for this is this one. So 2 multiplied by demand multiplied by S, setup cost, divided by the holding cost per unit, and this should be the square root. Take a look at this simple example. We have D 1000 unit as $10 per order. It is 0.5 per unit per year. How much Q optimum is equal to 2 multiplied by 1000 multiplied by 10 divided by 0.5, and then we took the square root and we have 200 units. So in order to minimize the cost, we have to each time we order at the size of 200 units. What is the expected number of order? So in this case, we can calculate simply by dividing the demand with the order quantity, which is 1000 divided by 200. It means within a year, we have to take 5 orders. And between order, we can understand that we have the number of working days per year divided by number of order per year. So for example, we assume that within 1 year, we have 250 days working divided by the 5. So it's mean for every 50 days, we have to make an order. Thank you so much for joining me in discussing about the first model of inventory management, which is economic order quantity. Let's extend this model into more complex one in the next video.
Thank you so much for joining me in Learning Operation Management. See you again in the next video.